This video is about solving rational inequalities. We're going to look at 3 different methods and depending on what you're presented with. So in question number 1, they're asking us to solve the inequalities and the solutions to f of x, which is this graph right here is f of x, when it equals 0, when it's greater than 0, or when it's less than 0. They give us a second graph, g of x, and we're asked to solve where g of x is equal to 0, where it's greater than 0, or where it's less than 0. So the first method we'll be looking at is when it's presented to you graphically. So this is the graph of f of x. If we look at this, there are asymptotes, and they've been denoted by dashed lines. They're not part of the graph. They just help define the graph. And the first question is, where does f of x equal to 0? This is for what x values does the y equal to 0? And there is one place right here on the x-axis is where it equals 0, and that happens to be when x equals to 0. So x equals to 0 is the answer, or in set notation, this would be the set containing the number 0. Where is this graph greater than 0? Well, that means where is it above the x-axis? So this is the x-axis right here. This is the y-axis right here. And where is it above the x-axis is everywhere it's above this line. So for what x values is it above the x-axis is what this is asking. Well, for these x values, from negative infinity to, this is negative 4. So from negative infinity to negative 4. And then not down here because it's negative or equals 0. And then it's positive again from x is 4 to infinity. Where is f of x less than 0? Well, down here, but it equals 0 at 0. So they didn't have a or equals to, so we don't include the 0. So this is from x is negative 4. As close as we can get to 0 without including 0. We have to hop over 0 because it didn't have an or equal to. And then from 0 to 4. These are the places where this graph is negative. Similarly, for g of x, where does it equal 0? Well, where does it touch the x-axis? In this case, never. It doesn't touch the x-axis. So this would be the empty set or no solution. The empty set is denoted by a set with nothing in it. This is no solution or the empty set, or whatever you click on my math lab, there's no solution. No solution to this is the answer. Okay. Where is this positive? Well, this is the x-axis, so it's positive for these x values, which is from as close as we can get to 3 to infinity. 3 to infinity. Where is it negative? For these x values, from negative infinity all the way to 3. Negative infinity to 3. Okay, that's how we would do number 1. Number 2, this highlights the second method we'll be looking at. The second method we'll be looking at to solve these is kind of by observation. Sometimes you're given a rational function which is easy to figure out the sign of things. And so there is a noise going on. I might pause this video for a minute. Okay, I think the noise is not as much now. So the second method, sometimes you're given a function that it's kind of easy to tell whether it's going to be positive or negative or where it's going to equal 0. A fraction, which is what a rational function is, rational means fractional, will only ever equal to 0 when the numerator equals 0. So if we look at this first one in number 2, 15 is 15. It does not equal 0. It will not spontaneously turn into 0. So the numerator will never equal 0. So the fraction will never equal 0. So this is no solution or empty set to this question. Now, where will this be positive? Well, if we look at this one, something squared will either equal 0 or it will equal something positive. Where does this equal 0? The denominator will equal 0 when x is 1. But that's not in the domain. X is not allowed to equal 1. So the denominator will be positive everywhere except for where it equals 0. So everywhere except for where x is equal to 1. If the denominator is positive and the numerator is positive, a positive divided by a positive is a positive, meaning that this rational function will be positive everywhere it is defined. Everywhere it is defined. So it is defined for all numbers except for 1. So where is this positive? From negative infinity to 1, and from 1 to infinity. When will this be negative? It will never be negative. It will either be positive or undefined. So this is no solution, or empty set. No solution. That's what that should be. All right, if we look at the second one, this one also can be thought about by just kind of inspection. If you look at this, this is x squared plus 3 over, if I factor out a negative 1, over x to the 4th plus x squared plus 5. Okay, so for any value of x, basically this is going to be positive in the numerator. For any value of x, 0, negatives, positive, we get a positive up here, okay? For any value of x, we get a positive in this parentheses times a negative. So a negative times a positive would be a negative. So a positive divided by a negative is negative, meaning that this rational function will be negative for everywhere it's defined. Well, it is defined for all values of x, because if you said x to the 4th plus x squared plus 5 equal to 0 and solve, you're going to get imaginary numbers. It will never equal to 0, because if we set the numerator equal to 0, we're going to get imaginary numbers. So when will this equal to 0? Nowhere. This is empty set, no solution. Where is this positive? Nowhere, because this is always going to be positive over a negative, no solution. Where will this be negative? Everywhere it's defined, and it is defined everywhere, from negative infinity to positive infinity. So sometimes you'll be given a function where you can just look at it and say, okay, these are the solutions. The next method we're going to look at is what you do. You can use this method all the time. How do you solve this? This has got a few steps. I'm going to show you how to solve 4, 5, 6, and 7. I'm going to put this in a second video.